Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the creation of arrays. Within your applications, arrays can be a very useful way of storing, accessing and manipulating your data. We have done a number of videos on creation of arrays and accessing their data. What we're going to cover today is some areas of array accessing and creating that we haven't covered before. So let's have a look at some code. Since we're going to be making use of some random data generation in this application, we're going to use the randomize command, using its single parameter of timer, to seed the random number generator with the current date and time. So firstly, we're going to create a one-dimensional string array with 5 elements. And having created this array, we're going to populate the array with some data using the array assign command. The array assign command takes the name of the array as the first parameter, followed by an equals sign, and then a comma-delimited list of the values you wish to put into the array. In this case, we're putting 5 values into the array. Let's now display this array on our log to see if they have arrived. So we're going to use a for next loop, stepping through each of the elements within our array. If we run our application now, we will see, although we have 5 lines of data appearing on the screen, only 4 of them are actually populated. So what's gone wrong with our code? One thing that might not be immediately obvious is when we dimensioned the array, we gave it the name of the array with the number 5 in brackets, intending to have 5 elements. However, what this has actually achieved is it has created an array with 6 elements, starting with the element 0, then 1, 2, 3, 4, and finally 5. And when we use the array assign command, we were going to put the value apple into the first element of the array. This is the 0 element. And because our for next loop is going from 1 to 5, it will only display those 5 elements. It will not display the 0 element, which is why one of them was missing. If you do not require the 0 element of the array, you can dimension the string slightly differently. So putting just 5 within the brackets is the equivalent to dimensioning it from elements 0 to 5. If you only want elements 1 to 5, you can dimension the array and in brackets put 1 to 5. In this array, there will be no 0 element. So if we run the code now, you will see all 5 elements are now correctly populated. Whether you have a 0 element or not in your arrays is entirely up to yourself. Sometimes having a 0 element can be useful, for example holding a column header name. The other thing that it's useful to do when accessing your array is not to assume the element size. At some points in your application, you may well redimension an array to change its size. Therefore, you need to have a nice dynamic way of working out what the lower bounding and the upper bounding of the array actually is. PowerBasic supplies 2 commands to achieve this: lbound for lower bounding and ubound for upper bounding. So in our for next loop, we can replace the for long r equals 1 to 5 with a new line of code. This line of code will work out the lower bounding value and the upper bounding value of the array dynamically. This way, your code does not need to change in the event of the array being redimensioned. So if we run that code again, it would give us exactly the same values, but this time the for next loop is dynamically working out how big the array is. The dimensional aspects of your array can sometimes depend on the data that you wish to put into the array. Say for example, we wanted to hold information based on the year. We're looking at storing information for the last 10 years, perhaps the number of staff that have worked from your organisation for each of those years. While we can dimension an array from elements 1 to 10 and put the values in, having something even more dynamic is quite useful. So let's create a one-dimensional array with an element for each year and store the numbers of staff working for each of those years. So what we have done here is create two local variables, one to specify the start year and one to specify the end year. And we're populating the start year with 2013 and the end year with 2023. So we're now going to dimension an array to hold the information we're going to put into that array. And we're dimensioning that array using these two variables from the start year to the end year. So the first element of the array will not be 0 or 1, it will be 2013. And the upper bounding of the array will be 2023. This way we can populate the array using the year number as the element. This makes the code even more readable. And the value we have which specifies the element could in itself be stored within another variable. So now that we've stored these two values against these 2 years, how would we print that out to our log? How would we access it from the array? So using the approach we used a moment ago, we're going to use L-bound and U-bound to work out the lower bounding and the upper bounding of the array. The return from the L-bound function in this case, for that particular array, the staff count array, will return a value of 2013, and the upper bounding will return a value of 2023. So if we run that code now, we will see we get the year coming out and each of the year numbers. And we're also getting out the number of staff for each of those years. So as we populated the years 2022 and 2023, we're getting the values coming out for those. So this shows that when you dimension an array, you have quite a bit of flexibility of the lower bounding and the upper bounding elements. So can we go further than just positive numbers? Let's say we wanted to create another one-dimensional array, but this time with an element number for each temperature, holding the number of days at that temperature. How would we go about doing that? Let's say, for example, we're interested in the temperatures of -10 to +5. So we can dimension the array from -10 to 5, and that will create one element for each of these values. We can then assign to that array some values. We can now use the array assign command to populate some values into the array. So we're populating the first 7 elements of this array. And now that we've populated that, let's use the same construct, the for next loop, using the lower bounding and the upper bounding, to print out to our log the temperature and the number of days at that temperature. So let's try running the code now to see what comes out. So there are our temperatures from -10 to +5. And the values for the first 7 are appearing on screen, from -10 to +5. As we have not populated the values for the other temperature values, they are all coming out as 0. So as you can see, the numbers you use for the beginning and ending elements of an array when you dimension them do not necessarily have to be positive. But they do have to be whole numbers. So now that we've actually handled one-dimension arrays, can we do the same thing with multi-dimension arrays, arrays of dimensions of 2 or more? Let's assume we're going to create a 2-dimensional array holding a day number in the first element and the rainfall in the second element. So this new array, the average rainfall array, is going to contain 7 rows, from rows 1 to row 7. And it's going to contain 2 columns, from column 1 to column 2. And we're going to populate that using a for next loop. So we're going to store in the first column the day number. This will be a number between 0 and 6, 0 for Sunday, 1 for Monday, and so on. In the second column, we're going to be generating a random number between 0 and 200. This will be the number of millimeters of rainfall. So we can report on each of the 7 days how much rainfall occurred. We now want to display on our log the data that's sitting in the array, using the L-bound and U-bound commands we've used earlier. So the for next loop is for the L-bound of the array, which in this case is 1, and the upper bounding of the array, which in this case is 7. As you will see, the L-bound and U-bound commands have an extra parameter. This optional parameter designates which dimension we are querying. Our array has two dimensions. The first dimension is basically the number of rows. The second dimension is the number of columns. So we are interested in the upper bounding of the number of rows, hence the (1). Having determined that, we are printing out using the inbuilt dayname command. Since we have stored a value between 0 and 6 in the first row, first element, we want to actually print out what dayname that is. The dayname $function will return the actual name of the day, starting with Sunday for the value 0. And our second column is the rainfall itself. So if we try running that code now, we will see we're getting the 7 days printing out on the log, and a random number generated for the amount of rainfall. However, we can make our code a little easier to follow. We can make our code a little more readable, and therefore maintainable. It's not immediately obvious that the first column is actually the day number, or that the second column is in fact rainfall. So we can set these up in constants at the beginning of our code. We can set up a simple enumeration. In this particular enumeration, we're setting up constants. We're using the singular command, so it means that the following line, in this case dayname, is the name of the constant, preceded with the percentage sign in your code. We're setting its value to 1. For the next constant, in this case rainfall, we've not given a value. Therefore the code will automatically populate that with the value 2. This saves having to put them all in specifically. So how would we put that in our code? If we comment out the 2 lines where we've hard-coded the column number, and substitute the 2 new constants, one for the day name and one for the rainfall. The code now becomes more readable. It's more obvious that we're storing the day name and we're storing the rainfall. As long as we use these constants through the rest of the application, we don't really need to know which column number that data is stored in. It's all handled by the constant. So we'll make the same change for displaying the data to our log. We'll comment out the original piece of code and we'll put a new piece of code in which specifies the day name and the rainfall constants. We've merely substituted day name where we've had the 1 for the column number. If we run the code now, we will see we get exactly the same result. We get the 7 days worth of rainfall. Hopefully you'll find these techniques useful in your applications. But that's it for today. Thank you for watching.